Hello everybody, Mr. Miller here, and we're going to be talking about negative exponents today. We're going to start with just kind of a general bit about negative exponents, and then we're going to delve into some actual problems from our current lesson. So this is some background information. It's very important to understand, and it'll give you kind of a fundamental base for what we're doing. You may have encountered this stuff before. I know that I have some areas in the upcoming curriculum where it'll show up before, but if this is your first time or you need a refresher, this is good little starting place. So we have 2 to the 4th power. 2 to the 4th power is 16. You may know that off the top of your head. You may not. That's okay. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 2 to the 3rd power, 2 times 2 is 4. 4 times 2 is 8. And 2 squared is 4. 2 times 2 is 4. And 2 to the 1st power, if you remember, anything to the 1st power is just itself. Anything to the 0th power is 1. Now this makes sense because if you multiply by 0, then you always get 0, but that's because it's repeated addition, right? And 0 is a fine place you can add and subtract from. With exponents, it's repeated multiplication. And if you multiply anything by 0, you get 0, so you can't use 0 as your base for exponents. So this makes sense. And we're going to see a pattern emerge, which is to get from 16 to 8, you divide by 2. To get from 8 to 4, you divide by 2. To get from 4 to 2, you divide by 2. And to get from 2 to 1, you're going to divide by 2, which makes us think that 2 to the negative 1st power is going to follow that same pattern. We're going to divide by 2. 1 divided by 2, well, the problem itself gives us the answer. It's 1/2. And we can do this again and say 2 to the negative 2nd power. So let's think about it. We've got 1/2, right? We've got this half over here, let's say. And then we are going to divide that by half, right? So we're going to cut it right here. And then we've only got 1/4 of the pi. So our answer here is 1/4. 2 to the negative 3rd. Well, we're going to again cut by half. We're going to take a look just here, right? And we think about how many pieces we had. Here were our fourths. Then we cut them in half. Now we have 1, 2, 3, 4, 5, 6, 7, 8 pieces, and we only have one of them. So this is 1/8. Okay, and that makes sense in a dividing by 2 standpoint. It makes sense in a pattern that exponents follow. But here's this really awesome other thing that shows up. I'm going to get rid of some of these arrows, right, so they're not distracting. But the other pattern that you're gonna notice showing up. Let's get ourselves just an awful pink apparently. The other pattern that you're going to see showing up is that 1/4. The reciprocal of 4. That means when 4 is flipped upside down. 2 to the negative 2nd power is the same as 2 squared, but upside down. To that same way, 2 to the 3rd is 8th, 2 to the negative 3rd is 1/8. So it's the same thing. When you raise it to a negative exponent, it's going to be the reciprocal of the original fraction. And then here we have 2 to the 1st power is 2, to the negative 1st power is 1/2. That makes sense. And so then we could extrapolate that 2 to the negative 4th probably equals 1/16. And that is true. That's the actual answer. So I just wanted to talk a little bit and reintroduce the reciprocal idea, reintroduce why that occurs, just so you got that in the back of your mind as we continue on, right? So let's take a look at our actual lesson problems, and we get something that looks like this: 21c squared w squared over 9c to the negative 7th w to the 11th, okay? And so we're going to swap out and take a look at our problem. Now, let's get our yellow back. I like our yellow. So, I'm drawing on the wrong layer. I can edit that out, right? Okay. So first, we can look at it. We have 21 over 9. And we can deal with this fraction right away if we want to. It has a greatest common factor of 3. 3 times 7 is 21. 3 times 3 is 9. So 21 over 9th simplified is 7/3. Okay. And then we have c, and we had c squared minus to the negative 7th power. Then we have w squared minus the 11th power. As we divide, remember, we subtract those exponents. That is in block 1 if you need to go back. That is in dividing monomials. Feel free to go back and review those anytime that you need to. So we have 7/3. C, so 2 minus negative 7. Well, 2 minus positive 7 is negative 5, but we're not subtracting a positive 7. So 2 minus negative 7 is the same thing as saying 2 plus 7. 2 plus 7 is 9. And then we have w, 2 minus 11, right? And 2 minus 11, you subtract 2 to get to 0, and then you subtract another 9, so you get w to the negative 9th. Now, the only thing that we need to deal with on this is the negative 9th, right? And we found out before, by looking at it, we remembered that having a negative exponent is the same thing as having a positive exponent, except it goes in the denominator. It's the reciprocal. So to have a positive exponent, we would just flip it down here and say 3w to the 9th. So we have 7 times c to the 9th divided by, or over, 3w to the 9th. And we can put that in. So we have 7 divided by 3. And I always put in my fraction first. That's just the way I do it. Sometimes it feels like it's hard to get the numbers where you want it to go. And if you start with the fraction bar, it just seems easier. So that's just me. Use it if you want it. Do something else if you don't. And we had c to the 9th. So we had 7c to the 9th over 3w to the 9th. Now, this is the first time I'm going through this lesson with you. I would expect you to go over here and say, how did I do? We've got a green barrier. That's good. If this were red, or if we wanted to just check our work, scroll down and it will give you steps by step. So my expectation of you is that you will complete this once, clicking how did I do for every single problem. And then you'll go through, if you got them all, if you feel confident, then go through again without using the how did I do button to practice a second time. Just because there are only 5 questions doesn't mean that you only have to do 5. You need to work until you can do it 100% of the time, right? That's what this practice set is for you. So if that is 10 problems, then go through it twice. If that is 30 problems because you're really struggling, you can go through it 6 times, click how did I do for 4 of those 6 sets, that's okay. But if you find yourself going through 6 times, that's another place where you might jump into open hours. On Tuesdays and Thursdays, you might send me an email, an iMessage, whatever you need to do. So this is the first one in this set of problems, and I'll see you soon for the next few.